welcome everyone to part 4 of vRealize Operations webinar series 2016. Manny, if you can hear us, can you drop a message on the chat window just to confirm?
Can Australia hear us?
Awesome, thank you. All right, so okay, so sorry for the delay, guys. I know we delayed by around 5 to 7 minutes, but we'll try to make up as soon as possible by bringing in some more and nice content today.
I will stay here all night, man.
So today's topic is contention-based capacity and performance management. The great news is that we will be using vRealize Operations Manager as a driver or a vehicle to help you do effective capacity and performance management by using a simple concept of contention. And that's what the idea behind this session is. So today we have 3 speakers, myself, Sunny, and you know the previous sessions as well. And then I have Iwan with me in the room. Iwan is a friend and a colleague who's been working around the area of vRealize Operations Manager and has written a bunch of books as well, a couple of them. We call them a bunch.
50 shifts of virtualization.
Yep. And we have Simon as well. I think Simon is a silent partner today. He's not able to speak much today, but he'll be helping us out if there are any questions from anyone on the window. Now, before we start, I just wanted to go ahead and quickly remind you of the housekeeping items. The session is getting recorded, so if you have a question, or if you have, or if you missed this, or if any of your friends have missed this, then don't worry about it. The recording will be posted within 24 hours of completing the session.
Within 24 hours. That's an SLA.
And we basically are taking questions as well. I would encourage that you use the chat window to ask your questions, and I will be able to go through them time and again and answer them for you. And at the same time, make sure that if you have questions which you want to take up at the end of the session, then I'll open the lines for everyone to speak, and we will take those questions one by one. All right, so moving forward, I would probably give it to Iwan to start with the slide.
Yeah, that wasn't planned. Guys, feel free to post your question on the chat window. Just address it to everyone. So because we had some technical difficulty, I was supposed to be presenting, but then we end up with a 3G connection here. So please post to everyone so we can see it. So performance and capacity management using the 2 products that we have in VMware, vRealize Operations and Log Insight. We have we made some effort to document it. You can actually see there are 3 books inside here. And it just happens that the 3 books were written by the members of the CTO ambassadors. Okay, let's proceed, Sunny. Next, okay. So how this DAC essentially started was a couple of years ago. I think this is a pretty common story, right? You were the VMware admin or VMware architect, and the VM owner come and complain to you. I'll speed up on this because this is a very common story, and later we'll relate back to it. The other one is also this one. I think you hear this feedback, or you probably make this kind of recommendations to your clients. That they will ask you, what should be the guidance or healthy for performing the VMware environment, and you might give this kind of guidance based on commitment ratio, based on utilization, right?
Yeah. So if you look at these statements over here on the slide deck, there are a bunch of them which we have used time and again. And we have been telling our customers to look at your consolidation ratios, your overcommitment ratios, the usage percentages, etc., to determine that how is the infrastructure performing. I think while these statements are not incorrect, they are not complete in my opinion, Iwan. And that's where we want to find out that what are the right parameters, what are the right counters which we should use to go ahead and measure the performance of my infrastructure.
Yes, and essentially why we say, yeah, go ahead, Sunny. Okay. And essentially why we say they are incomplete, you will see it in the slide. It's pretty common that we get requests from customers, and you probably get requests from your CIO that say, we need to be able to see things end-to-end, managers of managers, that kind of thing. Right? I think that is a good idea. The question is, how do you implement that? And typically, you have an idea such as this. Okay, we got an application that we serve. We have an infrastructure as a service, IaaS, which comprises of the storage network servers. All this is pretty okay, but when you actually dive a little deeper, you realize that it's got many, many components. SDDC isn't actually one or two components. There's a lot of things that you need to monitor, and they depend on one another. On top of that, the health of your environment actually is not just one aspect. There is performance, there is availability, which will impact performance. Naturally, capacity is and performance are related. And of course, you're also dealing with configuration, which can also impact the health of your IaaS. So the point here is they are, and essentially, and even if you can know all these things, you can have the relationship between your, let's say, your NSX to your vSphere to your VM kernel. You know all these counters. They don't actually tell how good the VM is being served. They focus on the infrastructure layers. They do not focus on the customer, which is the VM.
Yep. And if you look at it, there are two levels which we think are important to monitor in the SDDC environment, right? There are two levels. The level number one is the virtual machine itself, which basically are your customers. And they really do not care about how the other VMs in the infrastructure are doing, how your ESX servers are doing, what your storage is doing, etc. Those are the VM owners, the business, the application owners who only care about their virtual machines. So that is one layer to monitor. The other layer to monitor, as Iwan just mentioned, was a plethora of different tools and options which we need to monitor, such as networking equipment, hardware, compute, server, storage, etc., etc. Now, there are a bunch of things, right? So we are trying to determine that what are those two levels, and this we think are the two levels. One is the VM, the other is the infrastructure. And then within those levels, there are four different areas to monitor, as Iwan mentioned before, right? So we will look at probably a couple of layers, a couple of areas today, such as performance and configuration and capacity. But we're not able to cover everything in 1.5 hours, so we will try to see what all we can dive into. Let's move on. Let's look at the two distinct layers which Iwan mentioned. So the first layer, Iwan, I can see clearly is a consumer layer, which is the virtual machines. What do you think is important to monitor from a performance and a capacity standpoint in the consumer layer?
Okay, so if I'm a VM owner, right, what do I care? Well, I care about one thing. I care about the performance of my VM. Typically, the uptime, the availability is pretty good. So performance becomes the number one thing, right? And other VM is irrelevant as far as I'm concerned. Whether you are running other VM or you're running something else, it's none of my business, so to speak. If the performance is good, then I'm but at the provider layer, you as the person in charge of the VMware environment, you care that you are serving everyone's floor, not just that one or two VM. If the performance is okay, you're not having a performance problem, you're not firefighting a performance issue, then you can look at capacity. Because there is no need to look at capacity if you got a fire in hand, right? You got to troubleshoot that one first.
So if I understand you correctly, you're saying that the first priority for monitoring either at consumer layer or provider layer would be performance.
Yes.
And if performance is good,
then you look at capacity.
Then you look at capacity.
Because you can't look at capacity if you got a fire in hand. You got to fix that one first, right? So performance first, then capacity, then you. looked at configuration, availability.
Okay. So ideally, if you look at any infrastructure today, why do they do capacity management? And most of the times they do capacity management because they want to make sure that everything what they have implemented runs well. All the applications are served well. And hence, that's why you need performance and then capacity. And then you can move on to other business requirements, such as configuration and availability. So today, we will try to focus on performance and capacity. And then in later sessions, probably we can talk about configuration and availability as well.
Yep, happy to do that. But before we proceed here, just 2 minutes of commercial break. I just want to introduce, so Mani is a VMware architect in one of our customers, is a regional bank. He's got a large deployment of vRealize operation and also lock-in side, probably one of the biggest in Asia Pacific for lock-in side, and it will be wonderful one day to have Mani. Brother, I'm sure you are there for Mani to share his experience and coming in from a customers as opposed to vendors.
Yeah, definitely, guys. Thanks for having me here. Yeah.
Thank you. Okay. Thanks, Manny. And of course, he's got a blog, he's got a Twitter, so go and follow him. Go and
I've got it all.
Okay, now, let's dive in. We talk about performance and capacity. What exactly is performance, right? And how do you know that your IaaS is performing fast? Typically, customers say if the utilization is low, then it is fast. Okay, it's fast in terms of what? It's fast in terms of serving the workload. So you notice here already that you are defining performance, speed, in terms of your ability to serve workload, but then you are measuring it on your ESXi utilization. They're two different things. And you also know that, your ESXi utilization from going up from 10% to 50 to 90, it doesn't get any slower, it doesn't get any faster. I think it will be clear if we use storage as an example. Doing 10K IOPS doesn't mean it's fast. Returning all those 10K IOPS, for example, within a millisecond or within the SLA that you promised, now that is fast.
Yep. So, to that, Iwan, I have a customer who I spoke with, and he said that I have like 10 terabyte worth of space left on the storage array. So it means that can I add in more VMs to that array? And the answer from my side was no, because when I looked at the latency numbers, the latency was in high 30s and 40s. Yeah. Which basically means that he's already written or hitting that latency number, which can start causing performance issues from a storage IO perspective.
Yeah. So in this case, right, the storage utilization is very low, but it's got plenty of space. That is not that badly utilized, but it is actually unable to cope with the demand. Right? So we define performance. The word performance here is not by the utilization of your infrastructure, because as you know, your customers don't care, but it is by how well your IaaS serves the VM. Right? Fast is relative to your customer. You may argue that 25 milliseconds this latency is fast. If they don't accept that, you have a problem. You gotta have an SLA. SLA is your defense mechanism. Okay, so this is just again to iterate performance and capacity, because there are quite a number of confusions. Because we came from the physical world where performance of the box is essentially a one-to-one mapping to the capacity of the box. But in a SDDC, you have VM and you have infrastructure. So the capacity of your SDDC, its ability to serve, is driven by performance and availability. In the example that Sunny has provided, the capacity of the storage array is full because it is unable to serve the VM. So the performance is already not good, then the capacity is full. You notice inside here there is, I think we can use this one, Sunny. So this one is a little more detailed, right? It tells you the relationship. The top part is the VM, the VM utilization is not actually part of SDDC capacity. That is a VM right sizing, that is a VM capacity monitoring. You do it on an individual VM basis. At the bottom one, can you see the mouse? Actually, you can. Right? At the bottom part, that is your infrastructure utilization that determines your infrastructure capacity. But as we said in the previous slide, there is this thing called performance. And the performance is defined, in this case, in this example here, the VM contention. Are the VMs contending for the shared resources? And you do not want the VM to contend for the shared resource, be it storage or network or compute, more than what you promised. You promised 20 millisecond disk latency, then it's got to be 20. It's not less. Or less, right? So there is something in between the contention counters, and that is the performance counters. Any other counters is the capacity counters.
All right. So I think what we're trying to say is that if you want to go ahead and provide a gist of what you should monitor is the performance counters for monitoring performance and not the capacity counters, which you used to do in the physical world.
Exactly. Because in the physical box, right? Let's say you got a Unix box, the utilization of that IBM Power or Solaris is essentially the performance of the box. But here it's different. It is SDDC. Performance refers to VM. There is no such thing as, in a sense, IaaS performance. It refers to your IaaS capabilities to serve the VM. And when you talk about performance, the primary counter is the contention and latency. Utilization of your ESXi is largely irrelevant. If a VM is experiencing, for example, let's say 10% contention, whether your ESXi is running at 90% or 10%, the VM owners will not care. They say that my VM is slow.
All right. So let's just jump in. So Iwan, I believe that it's important that we tell everybody what is the dining area.
Sure. Yeah. So tell the story.
So I think the story behind this is that I believe we started going on the journey of explaining this concept even before VMworld 2015, right? And then when we went to VMworld, we wanted to go ahead and explain this concept in a very simple example or simple way. And that simple way was determined as soon as we were having a lunch in one of the restaurants. We were sitting inside the restaurant and we saw that there are two areas. One area is the dining area where we all were sitting and giving our orders and enjoying our meal. And the second area was the kitchen. And there was a clear demarcation between the kitchen and the dining area. Now, we immediately were able to relate that restaurant to our SDDC environments, wherein we think that the infrastructure which we build is basically the kitchen, and the consumers, the VMs which run on top of that infrastructure are basically sitting in the dining area. And if you look at a restaurant business, you need to ensure that your dining area is always happy before you could fix the kitchen or take care of the kitchen. If your dining area is happy, your business is going up, there might be mayhem inside the kitchen. Yes, you need to fix the kitchen, that's for sure. But first, you need to take care of your consumers.
The VM. Yeah. Let's take a look at it.
Yeah, which are VMs. So let's take a look at it and see how we can do that. So let's start with the concept of how a VM gets resources, right? I think this is a very simple slide, but very powerful and probably gives you the entire gist of this conversation as well. Good. Okay, so you can basically set up, give vCPU or RAM to a VM, right? You can provision, let's say, up to 4 CPU or 16 GB, and whatever you're giving to it or setting in the vSphere client is basically the provision.
So we call this the provisions value, right? Yep. Okay. Then you can set reservations, you can set limits, okay, which you shouldn't be doing that. And then there is this thing called entitlement, right? And we put it in that animated, cute little PowerPoint because we want to drive a message that is actually dynamically calculated. It is calculated by the VM kernel, right? And it takes into account the utilization, the limit, reservation, etc. And entitlement limits what the VM can use. A VM can only use what is entitled. And what you want in a healthy environment, what the VM demands is what it gets to use. That is what you want. That is a healthy environment. It gets to use what it demands. But if you are doing overcommitment, there is a possibility, if you have more vCPU than vCPU, there is a possibility of contention. The VM is demanding CPU resource, but at that point in time, there were other VMs. As a result, that VM experienced contention. And that is the counter that you need to measure. That counter tells clearly how good your IaaS is serving the customer.
Yeah, very important to understand that you will see that entitlement being lower than what is provisioned in scenarios where you have that overcommitment. Yeah, I mean, if you have a tier 1 environment where you have not done any overcommitment, then you might not see the entitlement being less. But only when you do overcommitment and there is a fight between virtual machines because the entitlement is low, then is when you will see excessive demand above what it can use, which is termed as contention.
Yeah. Okay, so now let's see. We're going to jump now into an actual dashboard that you can use to monitor your environment, to monitor the dining area. You know, customers were joking with us and telling us, Iwan, you know, my VMware environment would not have any problem had not been because of all these VM floating around. Right? So let's look at the VM. If you look after the VM, well, your environment is actually in good shape. Let's take a look at it. We should start with a single VM. You need to be able to manage a single VM before you manage everybody. Right? And then the second dashboard is large VM monitoring. It is common for customers to have over-provisioned VMs, and you know the impact your performance, right? And the third one being a shared environment, and this came from a real customer scenario. He was telling me that one of the VM was doing an IO meter or something, and he wanted to know which VM and what time. So 3 dashboards, essentially what you need to monitor the VM, the dining area. Let's move to the first one.
Okay, so a single VM monitoring, I mean, I think this is a most common scenario in every virtualized shop where a VM owner will call you, if you are the IT guy, and tell you that his virtual machine is running slow.
Yeah. So this was a story we shared earlier, right? So what? And this is how we answer it. You need to be able to show that your infrastructure as a service is serving the VM well. And the counter that you are showing is the 3 counters. Well, we omit the network, but we typically expect the network not to have drop packets in the data center. So if you are serving the VM well, that's it. The utilization of the VM in a sense is not part of your scope. Because when the VM owner asks for 8 CPU, your job is to give 8 CPU. Typically, you don't question that why you need 8, you just only need 7 or 6, right? They buy 8, you give them 8. Neither do we show here your ESXi utilization. Because again, you know the VM owner doesn't care. In fact, whether it was ESXi or something else, the VM owner doesn't care. Now, to complete this scenario, what we can also do, okay, if my infrastructure is serving the VM well, actually my job is done. But let me value add. So maybe because your VM is undersized, maybe when you are given 8 units, 9 or 10, okay, we can take a look at the utilization of the VM. But the main counter that you need to demonstrate is how well does your IaaS serve the VM, those 3 counters plus the network drop packet. And that's all that you need to show. And so this is an actual dashboard. As you can tell, we mark out some of the names because these are from live customers and deployment. So you give the help desk, or this is also for yourself, a widget. So the first widget here lists the VM. And a help desk can essentially search the VM from here, and when it searches the VM, automatically we plot the RAM contention. So in this case, your infrastructure is serving the VM well. There is no memory problem in terms of your infrastructure ability to serve the VM. You're doing a good job. The CPU contention here, they are hovering 10%, 25%, 30%. It is not a good number, but if your SLA is below that number, you are good. If your SLA is if your SLA is above 35, you are good, right? But if you promise, for example, 10% CPU contention, you obviously fail into the VM. There is no question that you need to do something at your infrastructure layers. The disk latency here, this is actually not good. And here we'll break it into the read and write latency, and because typically a VM has two virtual disks, one for OS and one for data, so we show two virtual disks inside here. In reality, you probably do not want to bind your SLA to each individual VM VK. You just want to take an average of the whole VM and because it is stable for you. So in this case, it is obviously the storage subsystem has a problem that is hitting like about 400 milliseconds. And so in this case, definitely you won't stand an SLA at this number. Now, just to complete the picture, you take a look at that. The CPU and RAM utilization of the VM is very low. So the issue here is not because the VM is undersized. The issue here, one, because of this storage, and two, because of a CPU, and there is no issue when it comes to memory. And that's essentially the dashboard. One dashboard you need to answer the question to the VM owner when an application owner comes to you and says, my VM is slow, is that because of a problem? In this case, it's quite clear the infrastructure is unable to cope. But if everything is clear here, just like the memory here, you can now confidently tell an application team, look, it's not because of my infrastructure. You guys, if any questions we can ask on the chat window, I'm going to proceed in the interest of time. Proceed, Sunny. Okay. That's it. So that was the first dashboard. The second dashboard, all those large VMs. I think let's just proceed. I think this thing, like you guys read, I think is quite clear. So I'm going to proceed to the next slide.
Yeah, so when we talk about the large VMs, this is basically a common disease across all customers. And what I've seen is wherever you go, they have VMs that have been sized in a crazy fashion because they were basically movements from a physical world to a virtual world, and now they have been created as big monstrous VMs. So with this dashboard, we are trying to find out which are those large VMs and how you can go ahead and right-size them so that you do not have contention. Because remember, if you have over-provisioning, is then when you get contention.
That's it. So what the first, hang on. Sorry. So the first thing we do is, let's say you have 100 large VMs, and you define large VM as those with, for example, 8 CPU and above, right? So that is large to you. And so you create a group that has all these large VMs. And what you do is you plot a line chart showing the maximum CPU utilization among all the large VMs. If this not so, if one out of 100 VMs at that time is doing 100% utilization because it spiked, then the number will show 100. It just takes 100%. So it's a very conservative line chart. So you can tell if the number is low, let's say the number is at that particular moment in time, it's showing, for example, 20%, not a single one of them is exceeding 20%. Your 100 large VMs are just doing very low utilization. Okay? So the number, when we ask customers around, they are telling us it should be about 80%, because at any given time, somebody will be doing a pretty high utilization. Now, you complement that maximum line with an average line, because it takes only one person to actually bump up their numbers, right? So you want to see this average number because it takes into account everybody, probably in the range of about 40%, because half of them will be high, half of them will be low, and they will average to about 40%. If the average is like 5%, that means most of them are basically oversized. And the thing about the line chart is it doesn't tell you the distributions among large VMs. You want to know quickly who are the biggest among the big VMs. And also it doesn't tell you visually at a glance how is the utilization among all these VMs one by one, right? So what you want to do, you want to create a heat map. You want to plot every single VM, all these large VMs, and you plot it by size of CPU configuration. So the larger the VM, the bigger the box. So your 32 CPU VM, I've got a customer with 32 CPU, and it will stand out because it's bigger. It will be 4 times larger than an 8 CPU VM. But what you do, you also color them by workload. And in this case, if it is high utilization, you want to show a red color because that means they are underutilized, they are undersized, that is not good. It has to be bigger. But on the other hand, if they are running at 5%, 10%, that is bad because what is the point of you giving them 16 CPU? I mean, they probably only need 4. So the 0% is black, it is bad, and 100% is red because it is bad. You expect 50% and you set it to be green. So you set 50% to be green. Okay? Let's just proceed with this, show them the dashboard.
Yeah, I think it will make more sense when we start showing the dashboard. Okay, so if you look at this dashboard and the top part of this dashboard, we are first showing you the utilization among the top large VMs which you have. So in this case, we created a group of 200 odd VMs which are 8 CPU or more.
Based on the lab, I changed it to
4 CPU. Okay. 4 CPU or more, and we are basically going ahead and creating a super metric which can tell us what is the max VM CPU utilization, which is the purple line, and what is the average VM CPU utilization. Now you can see over here that in our environment, we do not have any VM which has done more than 40 to 45% of CPU usage in this case. And at the same time, you can see that the average is ranging around 3 to 4%, which basically means that the utilization numbers are pretty low from a max and from an average perspective as well.
Yeah, and you notice we show a line chart because we want to show pattern, not just at any given, not just a point in time. This one is going back 7 days. So in the past 1 week, we are averaging basically less than 5%. And at any given moment, not a single one of them ever exceeds 50%.
And we're complementing that with showcasing you that which are those oversized VMs over here. And that's where the heat map comes into picture. Now within the heat map, you can see that they're ranging between 0 to 100%, with 0% workload being black, 50% being green, and 100% being red. So it's a clear heat map which can tell you which are the VMs which are black, and which means they are oversized, which are the VMs which are appropriately sized because they'll be green in color, and which are the VMs which are undersized because they will be red in color. Now, this is a graphical representation rather than looking at data. And it's pretty simple to figure out in this case that most, or in fact all my VMs in this environment are oversized.
Yeah, so in this particular heat map is useful. It's useful for you to actually put it on the projector on the big screen, right? So and that people see if the CIO is see it every day and every day he sees black color, one day his face will turn black because it clearly shows that there's a lot of wastage. Okay, let's proceed. I'll click it on, Sunny.
so I think we'll answer this one, and then we'll basically go through this slide, and then we'll answer the question.
Yeah, no problem. So now, if there is a problem, this is continuing just on the large VM. Okay, so you wanted to be able to drill down into an individual VM, into a single VM. So this thing drills down the utilization of the, let's say, the top 15 VM. You can change it to top 20 VM. And I can tell here that this particular VM is the highest utilization among all my large VMs. And what I can do, when I select it, I can actually drill down into the individual core of that particular large VM. Now, so this is just in case in the large VM of, let's say, 16 CPU, and you got 1 or 2 threads, but the other threads are idle, so you can see it here.
Yep. So this is the data which you will basically use to take back to the application owners.
Correct.
To request them to downsize their VMs. So I think the first part of the dashboard explains you in terms of what are the culprits, and the second part of the dashboard, which is this piece, helps you take the data back to the application owners and show them the reality in terms of why you are calling their VMs as culprits and why they should right size.
Yeah, and then the last one. So the thing about this line chart is it's kind of difficult to see the utilization. You know, let's say in the past 1 month, you will see a lot of lines here. This is where the forensic widget at the bottom here comes into play. As you can see here, there is a word 95th percentile. In the last 30 days, 95% of the time, the VM utilization is essentially just 23%. And so if you take, let's say, so in here it's quite clear that the VM, most of the time is low. 95% of the time, it is just 23%. That is how you present it to the VM owner, say, look, this chart clearly says that you are way oversized.
Yep. All right, I think at this moment we can take a logical break, and I can pull out all the questions which we have on the chat window.
Okay.
All right. Okay, so I think the first question we have is from Marcos, and he asks that could I consider the CPU contention affected by the disk latency?
Possible.
Okay, that was a quick answer. So it is possible that the CPU contention is there because the disk latency is causing the overall processing of the VM to go slow.
Yep. What?
All right, I think the other question is from Jeff. The contention dashboard you showed earlier, is that out of the box or a custom one? I like it as it is very simple yet powerful plus meaningful. So the answer, I think Jeff has been answered on the chat window, but the answer to that for everybody's benefit is that these dashboards which you are seeing are not out of the box. They're all customized, and you need at least advanced edition of vROps to go ahead and build these dashboards. And if you have enterprise, then nothing like it. If you want to build these dashboards in your environment, then you can go to Iwan's or my blog, and you will be able to get most of these dashboards out there and implement them in your infrastructure. Right, I think Manny has a point, and he says that I think the issue that holds people back from creating such cool dashboards, given how much data vROps pulls in and the number of metrics available to choose from, gives most people a head spin.
Scott, the answer is Scott. Money for you, 2 bottles of Scott, I think there will be no head spin. Yeah, Money, on a serious note, we hear the feedback. As you know, I'm flying this Sunday to Palo Alto. This is one of the projects that the CTO ambassadors are working with the MBU, with the vROps team, to exactly reduce the number of metrics. We hear it loud and clear.
Yep. And just as an interim, you have the dashboards available on our website, so you don't have to break your head. You can just go ahead and import them in your environment with a few simple steps, and you will be able to reap the benefits. Okay.
How to build that? Yeah, we're happy to do a session on that. More than happy.
How to build this dashboard?
I think we can do it with money, you know?
Okay. All right, let's do it. So, let's move further on the last dashboard.
VM right idea. Okay. VM right idea. This is another topic. That is the That is pretty interesting, and you might not like the answer. If you have 1,000 VMs, you focus on the last one, right? You don't focus on reducing from 4 CPU down to 2 CPU. You focus on the 16 CPU, etc. Now the second point, focus on CPU, not RAM, and I'll tell you why. In fact, the next slide will make it clear for you. You might want to guess what are these two screenshots. Which one comes from Windows? Which one comes from the guest OS, in this case Windows, and which one comes from vCenter? I think you know which one is which, and you know the other thing that is feasible is they are very different counters. Nothing about fixed-fault on the vSphere, nothing about commit, nothing about hash, and on the vSphere side, it's a different kind of counters. You see entitlement, you see balloon, they are different. So, and I want to give you an example. So you might say, Iwan, they are different, so what? You know, and does this become practical in reality? This is let's take an example of this. Okay, so this is the Windows 2008 Active Directory. This is actually in the VMware Admin lab, where I am the sysadmin of the lab. And so I know this this particular VM is a core component of the lab. And you notice the VM utilization here, the memory. I gave this VM 4 gig, by the way. And this is the data from the vCenter. You can tell these counters here, this is the memory workload counter, this is the memory active counters in vCenter. You notice they are hovering from 8 a.m. in the morning, and where's the mouse? Okay, 12 p.m., 4 p.m., they are very stable because there's nothing much in the VM except AB, and I don't run anything else on the VM. So what I did, at about 5, 6 p.m., I decided to install vRealize operations endpoint agent that gives me the visibility inside the guest OS. So I installed the agent. So you can tell that the agent is installed because it is collecting metrics. And you can tell that this is now the second metric coming from this VM. As you can tell, it's got a domain name this time around, because this is coming from Windows. And as those of you who are familiar with Hyperic, you will notice the naming convention follows Hyperic. So this is the visibility from inside Windows. The blue line is collecting data. But the funny thing is, that's all I did. And notice what happened to the memory active counter. It went to 100%. Now, at this moment, I want to make it clear that this does not mean that you cannot completely trust the counters in vCenter. That is better than nothing. In some situations, it can be misleading, and I just pick the worst situation here to drive a point. Most of the time, it's not like this, right? Because without that counter, you don't have visibility. So that is a good gauge, right? Without installing any agents. So, so basically there are 4 things here. So I let it run because I was puzzled why the numbers became like that. So I let it run. As you notice, there was 8 o'clock, it's still like that. 9 o'clock, being a good engineer, 10 o'clock, bedtime, I went to sleep. I was hoping that tomorrow morning it will fix by itself. So in the morning I get up, it was in the weekend, and I think it was October the 4th or 3rd. It's still not there. So I decided to do something, and I needed to do something that lasts more than 5 minutes, because I need because vROps collects every 5 minutes, right? So I need to show a log. So what I did is I just initiated patching. That's all it does. It's just patching. It's downloading, patching, and because I have not patched this Windows for about 2 years, doing a lot of patches. And you notice the two counters, sometimes it's higher, sometimes it's lower, and then it gets pretty close around this point. But at the area D, you notice that they are pretty close. Then I do something again, and then they're a little different, right? So I hope that drives the point that for memory management, unless you have visibility inside the ghetto app, it's probably better that you focus on CPU first, as opposed to tackling both, right? And if you need to look at memory, now this is how Windows do memory management. And I just want to, in the interest of time, I'm speeding a little bit here. Windows memory management is using cache. It is making use of the memory. The more RAM you give it, the more it's going to cache. It's exactly the same behavior with ESXi, right? And now with the 6.1 release, this is the counter that you can use in vROps to track that. Now, how do you do sizing? This is how you do sizing. I'm using the same picture. You want to be conservative sizing, you take into account the cache. You want to be a cost-effective sizing, you tell an application owner, let's not use the cache. The cache is there is because the Windows take advantage of the physical RAM, right? So there are two methods of doing the memory right sizing, whether you want to be conservative or cost-effective. But CPU, we can definitely do it. Right, and I think we showed to you earlier in the earlier example where you can go down to individual virtual CPU. So this thing is kind of the same thing, where you pick a VM and it automatically shows the individual CPU utilization. I'm going to skip that because it's the same thing. Now, I'm going to move to another product here. This is one of many Patrick's products. This one is related to the right sizing. If you may be asked a question by your CIO or senior management, which VMs hit high CPU usage and when? Can you give me a chart? I wanted to know. So you can tell here essentially, I query login type and I say VM name exists. The alarm type contains virtual machine CPU usage. As you can tell, that's exactly the alarm that you get to see in the center. And I use the word RAID. And it plots that and it grabs the VM, so I know exactly which VM, what time, how often. If you look at the message, the string underneath here, that's exactly the string you see in vCenter, in vCenter alarm. Now that's an example of the healthy environment. There are only 2 VMs that hit the problem. This is what it looks like in an unhealthy environment where there's a lot of VMs hit high CPU utilization at the same time. And it's marked out because this is for my customer. Okay, so just to wrap up, I think you know this thing already, so I'm going to skip that. We're not going to move to a third use case. Did anyone abuse your environment?
All right, so that was quite a lesson on right sizing. Let's move to some excessive utilization. I think with excessive utilization, Iwan, what I've seen is that it's like all you can eat sushi in a restaurant, right?
You like sushi?
I love it, and especially when you enter the world of virtualization, you are doing sharing. You put in a bunch of VMs on the same ESX server or same cluster of ESX servers, and on the same storage. Then how do you find out that which is the VM which is utilizing the most amount of resources and probably becoming a noisy neighbor for the rest of the VMs in the cluster, right? So there are various ways of finding it, but we try to simplify that to a single dashboard, which can help you to identify any of these resources, whether it's vCPU, RAM, storage, disk IOPS, or network. Now, with this example, we will basically go ahead and take disk IOPS and showcase that with the help of a dashboard. And you can use the similar concept for the other metrics as well, right? Okay, cool. So the dashboard for excessive utilization basically comprises of 2 things. One is a line chart, and this line chart is again using the principle of max and average. So it tells you that amongst all the VMs which you have, which is the VM which is doing the max amount of disk IOPS, and this will be plotted every 5 minutes. And at the same time, you can do the average of all the VMs using a supermetric doing this IOPS at the same timeline.
Yeah, so if the max number suddenly spike up, we know somebody generates a lot of IOPS.
Yep, absolutely. And if your max number is higher and way higher than the average number, then you also know that it's only one or two who are the culprit and not anybody else.
Correct.
Because if most of the VMs are going high in IOPS, then your average will also be pretty high at that point of time. And then we complement this with a heat map where we show you the size of each VM by IOPS and color the same by latency so that you understand that which are the VMs which are creating or doing the most amount of IOPS and are they experiencing latency at the same time, right? So you can use this for other concepts as well, just like network or CPU or memory, etc. So let's just go ahead and dive into this one. Here you can see that we have a timeline where we are showing the max and average IOPS for all the VMs. Now if you look here on the top part, we have a VM or we have one or maybe more than one VM which has done around 13,212 IOPS.
Yep.
Right? That's pretty high if you look at the overall numbers. And specifically if you look at the average has bumped at that point of time as well. However, the average is just around 15 IOPS, which basically shows that not many, but only one or two VMs have done that humongous amount of IOPS at a given point of time.
So the context of this was I was called by a customer that says that we got hit by somebody, we do not know when, we know it recently, and we did not know who. And they said, can you find out which VM did that? Yep. So we can zoom into that specific time, so we know it is about 3:16 in the morning, it is 13,212 IOPS. At that time, and that is a number, so let's find out which VM, and it's a matter of using a top end at this moment to list it, and we know the VM already.
Yeah, so basically we use top end at the same time to list with the IOPS metric, and we were able to figure out which was the VM.
Yeah,
fantastic.
Now, Sunny was saying about the heat map earlier, so you can see the distribution among your VM, and this is something that is pretty good on the big projector screen. You are expecting more or less equal distributions among all the VMs. You do not hope a single VM like occupying half of the critical estate here, because that means that VM generates more than half of the total IOPS. And Sunny said you plot it equal. You also add a color of latency, and you expect a color of green most of the time, showing that your storage subsystem is doing well in coping with the demand. And guys, that's it. If you are doing well on that 3 dashboard, you are pretty much doing a good job in serving all the VM.
I think we can take a quick look if there are any questions. I don't think we have any questions on the chat window. Fantastic. So guys, if you have any questions, you can put them in the chat window. We will just move forward and move into the next section. And this time we will talk about the kitchen or the provider there, right? So now since we've taken care of all the consumers in the dining area, now we move inside the kitchen and see how we can, or what dashboards we can use to monitor the kitchen and ensure that your SDDC or your IaaS business is working well.
Okay, so let's take an example. So let's say you have a service, you have three classes of service, and you have 200 VMs on 20 ESXi, that is a 10:1 consolidation ratio. On your tier 2, which is a cheaper tier, you bump it up, so that is a 16:1 consolidation ratio, and then your tier 3, you bump it up further, that is 25:1 consolidation ratio. That is fine, that is the general guidelines that you have. And then your CIO is asking you, okay, so I wanted to know that we are serving every single VM well. And they wanted to know also that if it is infrastructure as a service, let's monitor the 4 components of infrastructure: CPU, RAM, network, disk. And by the way, they said we measure performance every 5 minutes. So not every hour. We want to take it every 5 minutes, and we should, without fail, we meet the performance requirement. And by the way, let me have the data in the past 1 month. I want to see that we meet this requirement day in, day out. Now, let's take an example. Let's say you have 4,000 VMs. Multiply by 4 components of the infrastructure. Multiply by 12 data points in an hour, because 5 minutes. In 60 minutes, you have 12 data points. In 1 day, you have 288. And in 1 month, you have 8,650. In a month, that is exactly how much data you need to pass, because that is your performance SLA. The question becomes, how do you show it to a CIO on a single screen? We all use HADRS, so we know that VM do move from one host to host, be it because of host maintenance, or because of HA event, or because of DRS load balancing. And we also know that there are 2 scenarios. If you are conservative in your tier 1, you do not overcommit. So you're expecting a low or basically no contention. But in the tier 2 and tier 3, if you overcommit, you expect contention. So I'm going to use an example in the tier 3 and tier 2 where you overcommit. You also know that if anyone is affected, you wanted to know which VM and when, right? And you know that the 4 components of infrastructure are independent. VM number 7 may get hit on CPU. VM number 747 may get hit on storage. So the way we do it here, in order to give that meaningful information, is we are using the super matrix. We take the max and average to determine how VMs are being served. You have seen some examples that we have shown in the previous dashboard, right? Basically, let's look at, for example, CPU contention. Right? If you are promising 25% or below, and if the max number inside here is below 25, then you are good. So how do we put all this thing into a dashboard? So this is what it looks like. So on the side here, you have the clusters, right? So the map, because different clusters have different characteristics, right? And the different SLA, etc. So you click on the clusters. When you click on the clusters, it automatically shows the performance SLA and an actual data. So it shows actual and it shows threshold. And you want to see an actual below the threshold. If it is good, every single VM is good. The cluster is doing well. Same thing on the memory. You show an actual and you show a threshold. Right? So in this case, the cluster both fail and CPU and memory. Right? And then on storage here, I happen to set the SLA at about 5 milliseconds, which is rather low, and the storage is doing about 8. Right? So that's how we show it. Now, basically, if not a single VM is, if the threshold is not being breached, not a single VM is affected, is good. We are done. Okay, if it is not, you wanted to know which VM is affected and by what. So this is where the top end comes in.
Yep. So this is where you can basically go ahead and list all the VMs via these 3 different metrics, which we were looking at in the previous max and average screens. So you can basically use top N to list the VMs with facing top amount of CPU contention, most amount of RAM contention, and disk latency at the same time. So this will basically help you understand that which are those VMs which have breached the SLA, and hence you need to take some action from the infrastructure side to either increase or give a better tier for them to run on, or from the virtual machine side to see if they need right sizing, because in most of the cases you will see that oversized VMs will face CPU or RAM contention, and VMs which are not on the right storage tiers might face the disk latency.
Okay, good. And so that is on performance. We also know that the vCenter generates quite a number of alarms, right? So you might be asked again by the CIO, you know, what alarms are we getting? How often do they happen? Which VM were affected? You know, is there a pattern? You know, that kind of thing. So here is all the alarms in vCenter. And you notice here, I just do a single query, and this is actually an out-of-the-box field in login type. I just say it contains red. I say alarm status is red. That's all. And I group it by VM name. And again, CC underscore VM underscore name is actually an out-of-the-box field in login type. As you can tell, I have to mask out, because this is from real customer, so this is not a good example. Actually, there's a lot of alarms here, right? This is grouped by VM. I can tell. If you wanted to group it by, you know, what is the most common problems we have? I have a lot of VM being hit by alarm here, right? And they are red alarm. What is it? Well, I can group it by alarm type. And you can tell here that the most common problem that I have with this particular customer is a disk latency. Is the rate of having a farm grab. 27,000 alarms actually. Well, this is a pretty large environment, by the way. Right? And then you can also group it by the source of the alarm. You know, which VM or host are giving the most issue. Right? So I can tell here that this particular ESXi, I'm showing you the name now because it is actually taken from a different environment. This is taken from the lab in VMware. And that's it. Those are simple dashboards that you can use, not too many of them, to quickly check the health, the performance of your environment.
Yep. All right, awesome. So I think now we cover the performance piece for the dining area and the kitchen, and it's time to jump into capacity. So the good news is that you can go ahead and use the same concepts for capacity. For today's session, since we are bound on time, we will not go ahead and do capacity or cover capacity, but we will be doing it in one of our future sessions, right?
After many doing this session. But Sunny, I think we have to provide a summary.
Yes, absolutely. So the key things which we think are the key takeaways from today's session, and which you can immediately or go ahead and implement in your environment so that you can reap the benefits of spending this 1 hour with us. The first one is that you need to agree on a performance SLA, right? So that's your defense mechanism. If you do not have a performance SLA, it's very difficult for you or your customers, if you are a consultant like us, to go ahead and judge in terms of what is good or what is bad performance. The second is contention and not utilization. So we know that utilization is a capacity metric and not a performance metric. And hence, it's important that you measure contention and look at that particular metric. The third is that capacity is defined by performance. So if you have a large amount of capacity, does not mean that you will have the best performance in your environments. However, it's important that you first look at the performance and then take care of the underlying capacity so that you can take care of your overall environment. Okay, I think that's the end of the session. We'll quickly check if there are any further questions.
Open the line, unmute.
All right, we do that. I'm not that technical.
How do you unmute people, man? Is there a command line to unmute or power DLI or what? Oh, that's all. Oh, it's a GUI, man. Oh,
you are no longer muted.
Okay, everybody's unmuted. If you have any questions, you can go one by one. I think there's a question on the chat window that is the question recorded. The answer to that is that yes, the session is recorded and it will be posted on YouTube as we have done for all the previous sessions as well. just to go ahead and share screen and show you what you can find all the sessions. So if you go ahead and go to vExpress, which is my blog, or if you go to Simon's blog and some parts of Iwan's blog, you will be able to see the icon over here which says vRealize Operations Webinar Series. You click on the icon and you will be able to get all the parts which are recorded.
I think it's people. It's not background noise.
Yeah. Okay. So that's where you get all the recordings. And if in case you have any questions, feel free to go ahead and enter those questions.
You are now muted.
Or you can also post those questions on those blog links which we shared with you earlier on. With that, I don't see any more questions. I see, okay, cool. People are praising us, so it's a good day.
Is it?
Thank you, Jeff, for your comments. We will definitely come back with the next session next month, last Friday of the month or the third Friday of the month. I'll announce that on our blog post. So thank you once again. No more questions, and we close out the session now. Thank you, Iwan, for your time, and hopefully, pleasure. You stay on the journey for the years. Thank you, Ben.